So here, example 1, 3x plus 1 equals 7. Our first step is to isolate the absolute value. So right now, I see that I have an absolute value of 3x. Our goal is to get that absolute value of 3x all by itself on one side of the equation. Right now, is it by itself? I do my little whack. Is the absolute value of 3x all by itself on the left side? Or is something else over there with it? See how there's a plus 1? Okay, so it's not isolated yet. We need to get that absolute value of 3x all by itself on the left side. So I have a plus 1. How am I going to move this plus 1 to the other side? Do what? Opposite of plus 1? Minus 1. I subtract 1 on the left side. Got to subtract 1 on the right side. Plus 1 minus 1, dead. Gone. I'm left with the absolute value of 3x equals 6. And now my absolute value is isolated. It's all by itself. It's all by itself. So step 1, done. Now here's where things get a little bit different. This is the one new piece of information that's super important. Okay? We just talked about whatever numbers on the inside here, whatever it is, it's always going to come out as a positive number.
Because absolute value can never be what kind of value that is.
Can't ever be negative. So a good way to understand why we're about to do this, because we're about to set up two different mini equations to solve, because absolute values actually have two solutions. There's always going to be two solutions. We're used to only having one. The reason there's two is if I go off, we're going to take a little side quest. Off to the side, let's write down the absolute value of x equals 6. Okay, little side quest. What could you put in for x to make this equal 6? The absolute value of what equals a regular old 6? Yeah. The absolute value of 6 equals 6. What else could you put in there to make it equal positive 6? Yes. You could also do the absolute value of negative 6. That also would equal 6. So there are always two cases that will get us to our answer. In this little baby equation, I could plug in a 6 for the right answer. I could also plug in a negative 6 to get the answer. So the same thing happens up here. We're going to split this into two separate cases. Case 1 is where it's positive. 3x equals 6. The other case scenario is 3x can also equal negative 6. These are my two cases. Case 1, case 2. Because an absolute value is always positive, we're really going to figure out when can we equal positive 6 and when are we going to equal negative 6. Okay? These are going to give us our two answers. And now we have to solve two mini equations. Okay, so waterfall, and we're going to solve each of them to get both of our answers. To get rid of this 3, what am I going to do? Divide by 3. How am I going to get rid of this 3?
Same way, guys.
Opposite of multiply, divide by 3.
How we solve problems doesn't change based on the answer's sign.
These 3's go away. For case 1, x equals 6 divided by 3, 2. There's one answer. On the second case, negative 6 divided by 3 is negative 2.
What's the beautiful thing about algebra, Mr. Tokar? What do we know when we have a value for our variable? What can we do now to make sure that we're correct?
How can we check our answers?
It's not a trick. What can we substitute in now for x? Either what? Yeah, both of them should work.
If I plug in 2 for my original equation, the absolute value of 3 times 2 means what's the absolute value of 6? That's just 6. 6 plus 1 is 7. If I plug in negative 2, 3 times negative 2 is negative 6, but the absolute value of negative 6 is also just going to be 6. And 6 plus 1 is 7. Both work.
That's why we need to do 2 separate equations.
There are 2 solutions. So this is exactly the same as the warm-up. The only difference is after you get the absolute value by itself, you got to make 2 little mini equations to find both answers. Okay, we got 3 more to go. The next 3 are going to go quicker.
You may have explained it, Mr. Cookman, but do you guys know why absolute cannot be a negative value? What is absolute value? The definition is the distance on a number line from 0. Can we ever travel a distance and then have it be a negative amount? No, you can't say I walked negative 2 miles to the store. That's why. It's just based on the number line, the spaces.
Yep. Alright, example 2. Okay, so I have the absolute value of x minus 3 plus 4 equals 11. Start with your waterfall. We're going to follow the same 3 steps every time.
It's like we just added a term in there.
Looking up above, step 1 is to isolate the absolute values. Right now, I see I have the absolute value of x minus 3. And that needs to be by itself before we can set up our 2 cases. You can't set up your 2 cases unless the absolute value is all alone. It's not all alone, is it, Darren? This isn't all alone, is it? What else is over here on the left side? A plus 4. We have to move it. And we know we do the opposite. So what will I do to both sides? Subtract 4 on the left, subtract 4 on the right. On the left, they die. Left with x minus 3 equals 11 minus 4, which is 7. Step 1 done. We isolate the absolute value. And now we have to set up our 2 cases. So what's our first case going to be? It's going to be what's inside the absolute value, x minus 3, equals, we know can equal both positive 7 or negative 7. So the first one we're going to do positive 7. Our second case is going to be x minus 3 equals negative 7. And solve your 2 baby equations. Draw your waterfall. Solve your baby equations. Wah. Wah. What's nice too is when you solve your baby equations, you're going to be doing the same exact steps because the left side's the same for both of them. So step Step 3, solve. What are we going to do to both of the cases? What are we going to do to both sides?
Subtract the 3.
Right now it's already a -3, so the opposite is?
Plus 3.
Add 3. Add 3. Our 3's die. Our first solution, I forgot plus 3, is x equals 10. And on the other side we have x equals negative 4. Done. Those are our two solutions. Questions? No, they're not always going to be the same numbers, one positive, one negative. I know our first example was positive 2, negative 2. It's not always going to be like that. They don't have to be the same numbers, one positive, one negative. Your answers can be two entirely different numbers. Alright, example, a 3. Same thing. What's the first thing you do after your waterfall? What's the first thing you should do? After your waterfall. Yeah. Before you set up your two cases, what do you have to do first? We have to add the 3 to both sides because you have to get the absolute value and everything on the inside by itself first. I can't set up my two cases yet until it's just absolute value on one side. So we're going to have to do the opposite, which is to add 3 first. Okay? One of the biggest mistakes students make on this topic is they like to just right off the bat be like, oh, 2x plus 5 minus 3 equals 6, and 2x plus 5 minus 3 equals negative 6. You can't set up your cases until the absolute value is by itself. After adding 3 to both sides, now the absolute value is by itself, and I want you to set up your two cases. Set up case 1, case 2. And solve for x. Set up your two cases. And you notice when we do set up our two cases, we get rid of the absolute values. Us setting up two cases is how we get rid of the absolute value signs. So we can continue to solve. Okay, check your two cases. Do they look like this? 2x plus 5 equals 9, and 2x plus 5 equals negative 9. Now it's time to solve for x. Okay, instead of just having one step, we have two steps for both of them. equations are a little less mini this time. When you see equations like this where there's more than one step, you always want to get rid of what's not connected to the x first. So here, we would want to move our plus 5. We want to get rid of that plus 5 first, before we worry about the 2 that's attached. Okay? So for both of these problems, you should subtract 5 on both sides. When I do that, my 5's are gone. So we have 2x equals 4, and 2x equals negative 14. Good so far? Any questions on why we did minus 5 and didn't divide by 2 first? Now we're going to get rid of the 2 connected to the x, and we're going to do that by dividing both sides by 2. 2's go away because 2 divided by 2 is just 1. X equals 2. And x equals negative 7. Boom, boom. There's our 2 solutions. If you ever were in a pinch and you needed to check these, like Arenik said, you can always substitute, but a really quick way to substitute is in Desmos, you can type in this whole entire equation exactly how it looks, and then you just delete the x and plug in whatever your x value is. And it would pop up with either equaling 6 or not equaling 6. Good way to check. Okay, so our answers would be 2 and negative 7. We got one more to do, and we're done. Example 4. 2 times the absolute value of 3x minus 2 plus 8 equals 20. I threw in a little extra thing here. Do you see what it is? Yeah, there's a 2 out front. Now, what do you think a lot of students try to do with that 2? They try to distribute it. Absolute values, although they look a lot like parentheses, don't they? They are not parentheses. They do not follow the same rules as parentheses. We cannot multiply the 2 and use the distributive property. Okay, that is something we cannot do. So, our first step is still the exact same. We need to isolate the absolute value. So, on my absolute value of 3x minus 2, I need this to be all by itself. So, I need to move the positive 8, and I need to move the 2. The absolute value needs to be all alone before I can set up case 1 and case 2. So we know how to move the plus 8, easy peasy. How do we move the plus 8? Yeah, we do the opposite, minus 8. Just like we were doing for that, easy. Left with 2, absolute value of 3x minus 2 equals 12. Okay, easy peasy, just like we've been doing. That's nothing different. Right now, the 2 and the absolute value of 3x minus 2, they're being what? What operation? Like if I had to put an operation in between these, what would it be? When things touch in math with nothing in between, they are being multiplied. This would be read 2 times the absolute value of 3x minus 2, or I could say 2 multiplied by 3x minus 2. Or I could say the absolute value of 3x minus 2 times 2. They're being multiplied. When things in math touch and there's nothing in between, they're being multiplied. And that's important to know because in order to get rid of the 2, I have to do the opposite. We know it's being multiplied, so the opposite would be to divide both sides by 2. When I divide this side by 2, I have to divide the other side by 2. What happens when I do 2 divided by 2? You get 1. Right? And we don't need to write the 1 because what's 1 times something? Whatever it is, it stays the same. So that 2 is gone. We got 3x minus 2 in absolute values equals 6. And now the absolute value is all by itself. It is all by itself. And now you can set up case 1 and case 2. Turn it into your 2 baby equations. These are going to have some decimals. You can leave it as a fraction. Case 1. Case 2. My first case is 3x minus 2 equals positive 6, which means my second case will be what? 3x minus 2 equals negative 6. Solve your 2 baby equations for your 2 answers. Waterfalls. Wah. Wah. Set, practice solving these. Done already? First step though is correct. Just gotta do both sides. Here's what your first step for both should look like. Right now there's a minus 2. I'm doing the opposite, which is to add 2. Add 2 to the left, add 2 to the right. Okay, when I add 2, I get 3x equals 8 for case 1. And I get 3x equals negative 4 for case 2. Now all I have to do is, how do I get rid of the 3 that's attached? Remember, these are touching, they're being multiplied, so the opposite would be to divide. And you guys are big enough and far enough along in math where when we have gross, nasty decimal answers, it's actually better to keep them as fractions. Can you divide 8 by 3 and get a nice whole number? No, so we're just going to leave it as 8 over 3. Okay? We're at a point where it's better for us to not write decimals because we don't want to have to round. It's better to keep your answers pure. Can't divide negative 4 by 3, so I'm going to leave it. X equals negative 4 over 3. Those are the 2 answers to that absolute value.